Ladies and gentlemen, welcome back. Professor Connect here, bringing you guys another video, this time going over percent composition. So, why am I picking up here? Well, percent composition is something that I personally, as a chemistry teacher, actually try to use to build off of for my own chemistry students. I actually think this is a really great place to build on prior knowledge that you should know in previous math classes, like way back in like 7th and 8th grade math. And on top of that, it's also a really good jumping off point because I can make connections from here based off of different things that we've learned. Things like naming makes connections here. Things that we will learn, such as balancing equations and stoichiometry, they all make connections, or I can make them all connect through percent composition. So I feel like it's a really good middle ground to start. Now, up here I have the definition of composition, just in case I need to make sure we're all on the same page. Composition is essentially the makeup of something, right? What something is composed of is its makeup. So we say it's its composition. And the other thing is percent. Well, a percentage is the part over the whole multiplied by 100. And you guys have been doing this for a very long time. Like I said, some of you guys probably learned this maybe even as far back as 5th grade. Like, for example, if you have 4/5 of something, let's say you have 4/5 of a pizza or something like that. Well, you would say 4/5, I could take these two and divide them by each other. Doesn't really matter to me the method that you use, but you would get something like 0.8. Once you get that 0.8, you multiply it by 100%, or as some of you guys may have learned in other math classes, move the decimal place over 2 spots to the right. It's always 2 spots, no matter the decimal, always 2. And this becomes 80%, right? Or another comparison, instead of 4/5 of something, let's say you got like 4 out of 5 on a quiz or a test or something like that, and then you can figure out the percent composition. So is the part over the whole, or sometimes it's easier for students when I say the part over a total. Okay, so that's kind of like the background. Now, percent composition when it comes to atoms and chemistry. Well, this becomes a little bit more interesting because if I gave you a molecule to start with, something a little easy, C6H6, what some of you may eventually come to know as something called benzene. This is an important molecule in organic chemistry, but anyway, that being aside, this molecule is actually pretty nice for us to use as an example, because some of you, when you think of the makeup, you're going to think of just the count, and you're going to go, oh, there's 6 of these and 6 of those. So that means this is 50% and that's 50%. That is not what we are doing. Percent composition is actually based, so this is based on mass. It's almost always based off mass. Now, I know what you guys are thinking. Well, wait a second. I'm not given mass here, so how do I find the percent mass of something I don't have the masses of? Well, what we're going to do is we're actually going to use their atomic masses from the periodic table. So, for example, I'm going to find carbon, I'm going to find hydrogen, and I'm going to find their atomic masses. So if you guys take a minute, pause the video and find them. Otherwise, I'm going to write them down. So carbon should be 12.011 grams per mole. Hydrogen should be 1.008 grams per mole. So once you guys have those masses, then we can actually do some calculations, right? This is their atomic mass, otherwise known as their molar mass, and this is what I'm actually going to use to find their percent mass. So for example, I'm going to take these and I'm going to say, well, this is its mass. I have 6 of them, so I'm going to take this, I'm going to multiply it by 6. So I'm going to take carbon's mass times 6, and I'm going to take hydrogen's mass times 6 as well. So essentially, I'm just going to multiply both of these guys by 6 to get me my total mass for each. That'll get me just a made-up total mass for each of them. If I do out each of those calculations really quickly, I could say something like, well, this is 72.066 grams per mole. And hydrogen is going to end up being 6.048 grams per mole. Okay, so now I have 2 parts. Now I need to find the total. So basically what I'm going to do is exactly what you probably would guess. I'm going to take them and I'm going to add them together. When I do that, I'm going to have a total mass now of 78.114 grams per mole. And you guys can check my math if you would like to. That is a-okay with me. But this is essentially like phase 1. I need the parts and I need the total. So that's like my first phase. So now I want to find the percent. So if I want to find percent carbon, I'm going to take only carbon's information and incorporate it into my answer. And I'll repeat the same process with my percent hydrogen. I'll just repeat that same exact process. So with carbon, I'm basically going to take, well, what's its total? Its total for this molecule is 72.066. That is 72.066. I'm going to take that number and I'm going to divide it by the total mass, 78.114. And I'm just going to take that number and multiply it by 100 when I'm done, and it'll get me an answer. The answer is going to come out to be 92.257%. That is my percent makeup of carbon in this molecule. So carbon weighs like 12 times more than hydrogen. So it should make up a bigger majority. Then I'm going to take hydrogen, I'm going to take 6.048 and I'm going to multiply or divide it by the 78.114, and I will then multiply that by 100, and I'll get the rest of that 100%, right? Because these two should add up to be close to, if not perfectly, 100%. So this should be 7.743% hydrogen. So I have my percent carbon and I have my percent hydrogen. If I were to add those two together, it should come out to be roughly 100%. And that's going to be my percent composition. I'm going to do one more example with you guys. Trying to keep this video a little short, but also want to do at least one more. That way it's not just like a one and done thing. Percent composition, the other molecule that I'm going to use here, I'm going to use one with parentheses in it, because usually whenever I throw this onto a quiz or test or anything like that, or even a homework assignment, students oftentimes just panic. They see the parenthesis and they don't know what to do. So first thing I'm going to do is I'm actually just going to look up these masses real quick, just so I have a good footing. So calcium is going to be 40.078, oxygen is going to be 15.999, and hydrogen is going to be 1.008. Okay, so here's where this gets a little fun. I like to describe it like this. If you see parentheses, know that you're going to be multiplying something. The 2 on the outside means everything inside of it gets multiplied by 2. It is similar to multiplication inside of mathematics. The 2 goes into the parentheses. The element on the outside does not. The element on the outside stays by itself. You don't do anything to it. It just stays by itself in most cases. Just worry about the 2 on the outside. It multiplies in, and it must be a small 2 or a subscript 2. Okay, so we will multiply all those through. So basically, I will keep only one. That's multiplication symbol. I will keep only 1 calcium. I will have 2 oxygen. I'll have 2 hydrogen. And once I do each of those calculations, I will end up finding my mass for each. So my mass for calcium is going to be pretty easy. That's going to be 40.078. Oxygen is going to become 31.998. And hydrogen is going to become 2.016. Okay, now keep in mind, these are the molar masses, which means all these are grams per mole. Every single one of these. I'm going to add them together to get a total. So I'm going to have a total. That total is going to be equivalent to 74.088 grams per mole. Again, pause the video at any point if you need to. Try to catch up. Go back and rewind. Just make sure you're picking up on every little bit that we're trying to get across here, okay? So in the second example now, I'm going to kind of break this down, right? I have my masses, I have the percent, or I have the total molar masses. Now I'm going to find the percents. So I'm going to do kind of these in order. Percent calcium is going to be its mass, 40.078 divided by the total, 74.088. And I'm going to take that and multiply it by 100. And this will get me calcium should be equal to 54.080%. My percent oxygen will then be 31.998 divided by 74.088. Again, I'm going to take that number and multiply by 100 to get my actual percentage. This is going to come out to be a 43.189%. And my last guy here is going to be hydrogen. Hydrogen is going to be the smallest amount. You guys can probably tell by now. It's going to be extremely small compared to the other two because hydrogen just is not a big atom. Hydrogen is only composed of 1 proton and 1 electron normally. So that's why its atomic mass is so small. Once I take this and I multiply it through, I should get 2.721%. Obviously, this is for hydrogen. So if you were to take all of these masses and add them together, they should always come out to be 100%. That's kind of a good way to check yourself if you ever need to, is make sure that they add up to 100 or close to. Some of these problems will only come out to be like 98 or 99%. But I hope this was a good introduction for you guys. Hopefully you kind of get the basic idea of what we're doing when we're finding percent composition, a reminder of what a percentage is, and just two different examples, one being a little more complex, just that way you guys can actually get a feel for this. If you have any questions, leave them in the comments down below, and I hope to see you guys in the next video.